First, before we begin, we need to look at some terms that will be important when learning about Eulerian circles and paths. Firstly, a graph. A graph is a set of points or vertices and line segments or edges that connect said vertices. A vertex is a point where lines or edges connect to one another. An edge is a line that travels between vertices. A circuit is a path that starts and ends on the same vertex. A path is a track that begins and ends at different points. Now, with that in mind, we're ready to explore Euler circuits and paths. Euler circuits were named after a man known as Leonhard Euler. Leonhard Euler was a Swiss mathematician from the 18th century. He, along with many others, were historically tasked with solving a problem now known as the Seven Bridges of Königsberg. In Königsberg, Prussia, there were 7 bridges that connected 4 landmasses along a river known as the Pregel. The problem they were all presented was that of finding a path through the city that had a person crossing each bridge only once. Euler showed that this was an impossible task, and the information he ended up writing about is thought as the first history of graph theory, and led to it becoming a new branch of mathematics. What is a Euler circuit? A circuit is a graph that connects different dots with lines that represent connections between different items. For example, cities with roads that connect them to each other, or a set of people who have friended each other on a social media site. But when it comes to a Euler circuit, it is a graph where you can start at one vertex of, following the edges and touching every other vertex only once, then returning back to the original vertex.
What is a Euler path? A Euler path is a path that only uses every edge once. A Euler path happens in a connected graph that has 2 vertices of an odd degree while the others are even. The difference it has from a Euler circuit is that it does not require you to start and stop at the same vertex. An example of this is seeing a map of a route with different roads, but none of them are covered twice.
Hi, I'm Colleen Driscoll, and today I'll be talking to you on how to solve an Euler circuit and an Euler path. The Eulerian graph theorem is when a connected graph can be called an Eulerian. This is only when every and each vertex of the graph is of an even degree. This is the best method to resolve if the graph is an Euler circuit. There is proven consistency that when a vertex is of an odd degree that there will be no Euler circuit, and that if it does pass the Eulerian theorem, then it will have an Euler circuit. The Euler path theorem is when a connected graph can have an Euler path. This is only when the graph has 2 vertices of an odd degree, and then the rest of the vertices must be of an even degree. The Euler path must start at one of the vertices as with the odd degree, and then end at the other odd degree vertex. And this theorem is made true by how an Euler path does not have to return to the same vertex as where it started. These are some of our examples of an Euler circuit and an Euler path. You can see that in Euler circuits that they all have even degrees. And in the first picture you can see the Euler circuit, how it goes from A to D, D to C, C to B, and then back to A. And then you can also see in the Euler paths of how there is only 2 vertices with an odd degree, and then the rest are all even degrees.
So I will be explaining how to solve an Euler path and an Euler circuit. So we're going to start off with the circuit. And with the circuit, you want to make sure all of the degrees are even. And the degrees are the points at which the edges meet, and the edges are the lines. So we're going to count the degrees right now. D has 4, B has 4, E has 4, G has 4, A2, F2, H2, and C2. So we can check that they are all even. Now we are going to create the circuit. So this needs to start and end at the same degree. So we're going to start with D and end with D. And you can pass through the vertexes or the degrees as many times as you need, but you can only pass through the edges once. So I'll show you guys how to do that. So D, F, G, E, H, G, D, B, E, C, B, A, D. So we started with D and ended with D. We can go over that again. D, F, G, D, F, G, H, E, G, D, B, C, E, F, G, E, B, B, E, C, B, A, D. So that would be the circuit. Starts with D and D, all even degrees. So now we're going to move on to the Euler path. So with the Euler path, you still want to cross all of the edges, but you do not have to start and end with the same degree. But this one's a little different. You want to start with an odd degree. There can only be 2 odd degrees, and the rest can be even. So with this one, we have B, which is 3, D, and 3. Then C, 2, A, 2. So we can therefore say this is an Euler path because there's 2 odd degrees and the rest are even. So you want to start with your odd degrees. So I'm going to start with B, go from B to C to D to B, A, and D. Do that again. B, C, D, B, A, D. We went through all the edges, but we started with B and ended with D, sorry. And that is how you complete an Euler circuit and Euler path.